Have you ever paused to ponder the significance of electronic ports in your daily life? A question that might seem a tad trivial, yet it holds immense importance. Electronic ports, these tiny physical interfaces, have been instrumental in shaping the digital world as we know it. Let's embark on a journey back in time to the genesis of these ports, starting with the oldest known port, the parallel port. But before we delve into that, let's take a moment to understand what a port really is. In the realm of electronics, a port is a physical docking point using which an electronic device can be connected to another device. They facilitate the communication and transfer of data between electronic devices. Now let's turn the clock back to the early 70s. It was a time when computers were gigantic machines and printing documents was no less than an ordeal. This is where the parallel port came into play. Its invention marked the dawn of a new era in the world of electronics. The parallel port, also known as a printer port or Centronics port, was primarily used for connecting printers and other peripherals to computers. It was a wide, rectangular port, typically consisting of 25 pins in a cluster. It functioned by transmitting multiple bits of data simultaneously in parallel. This was a significant upgrade from previous interface standards, which could only transmit data bit by bit. The parallel port was marvelously efficient for its time, allowing for high-speed data transfer between the computer and the printer. It was a game changer, making printing documents a breeze and streamlining many other processes. So, who do we have to thank for this groundbreaking invention? The credit goes to a company called Centronics, who pioneered the parallel port in 1970. This was the first step towards a revolution that would transform the landscape of electronics for years to come. The parallel port, invented by Centronics in 1970, marked the beginning of a revolution in the world of electronics. This was just the start of an incredible journey, one that would continue to evolve and innovate, shaping the world of technology as we know it. As technology advanced, so did the need for more efficient and faster ports. Let's take a stroll down memory lane and delve into the evolution of electronic ports. Our story begins with the parallel port, a type of interface found on computers for connecting peripherals. Invented in the late 1970s, it was widely used for connecting printers and external hard drives. Its name comes from the fact that the data is sent in parallel, or multiple bits at once, over several wires, speeding up data transfer. However, it had its limitations, including a bulky connector and short cable length. Enter the serial port, an innovation by IBM in the early 1980s. The serial port streamlined the data transfer process by sending data one bit at a time in a series over a single wire. This made it ideal for long-distance communication, and it quickly became the standard for connecting modems and mice. However, it wasn't without its shortcomings. The speed of data transfer was slower than its parallel counterpart, and it required precise timing to function properly. Not one to rest on their laurels, IBM came up with another breakthrough in 1987, the PS2 port. Named after IBM's Personal Systems-2 series of personal computers, the PS2 port was developed for connecting keyboards and mice. Its smaller, round connector was a notable improvement over the large, unwieldy connectors of parallel and serial ports. It also offered a faster data transfer rate, making it a popular choice for many PC users. But why were these innovations so important? Well, they were instrumental in improving the speed, efficiency, and versatility of data transfer. They allowed for the connection of a wider range of devices, paving the way for the rich ecosystem of peripherals we enjoy today. These advancements led to a surge in the development of more sophisticated and versatile ports. The year 1996 marked a significant milestone in the history of electronic ports. It heralded the birth of the Universal Serial Bus, better known as the USB port, a brainchild of Ajay Bhatt of Intel. The USB port was designed to standardize the connection of peripherals to personal computers, both to communicate with and to supply electric power. The initial iteration, USB Type-A, was the quintessential rectangular port we've all come to recognize. It was mainly used to connect devices like keyboards, mice, and printers to computers. Then came USB Type-B, a square-shaped port, typically found on larger devices like printers and scanners, which required a different type of connection. As technology advanced, so did the USB designs. The mini USB, followed by micro USB, were developed for smaller handheld devices like cameras and mobile phones. They were smaller, thinner, and allowed these devices to be made more compact. However, the true game changer arrived in 2014 with the introduction of USB Type-C. This port, with its reversible plug orientation and cable direction, was a major leap forward. It could handle power, data, and display over a single connection, making it the most versatile USB port to date. But what made USB ports stand out? Why did they become so universally adopted? The answer lies in their simplicity and versatility. USB ports offered a standardized solution to connect a diverse range of devices, eliminating the need for various specific cables and ports. Moreover, they were backward compatible. This meant that newer versions of USBs could work with older ones, ensuring that devices were never obsolete. This era of USB ports also brought with it the concept of plug and play. Devices could be connected or disconnected without restarting the computer or installing additional software. This ease of use, coupled with their versatility, made USB ports the go-to solution for electronic connectivity. The invention of USB ports revolutionized the way we connect devices today. And as we look towards the future, one thing remains certain. The legacy of USB ports will continue to shape the evolution of electronic ports for years to come. The dawn of the 21st century brought with it a wave of innovative electronic ports. This exciting era saw the birth of several game-changing technologies that have since become integral parts of our everyday lives. Let's start with the HDMI port, an acronym for High Definition Multimedia Interface. Born out of Silicon Image's innovative prowess in 2003, HDMI revolutionized the way we experience audio-visual content. This port allows us to transmit uncompressed video data and compressed or uncompressed digital audio data from an HDMI-compliant source device to a compatible computer monitor, video projector, or digital audio device. It enabled us to bid farewell to the plethora of cables we once needed for audio and video, providing a one-stop solution for high-quality digital transfer. Next up, we have Thunderbolt, a collaborative invention by tech giants Intel and Apple in 2011. Thunderbolt ports amalgamate the strengths of PCI Express and DisplayPort into one powerful interface. They allow users to connect multiple devices, including monitors and external hard drives, using a single compact port. With its ability to deliver high-speed data transfer and high-definition display through one cable, Thunderbolt has truly simplified the digital workspace. Our final stop on this journey through the advent of modern ports is USB-C, brought to us by the USB Implementers Forum in 2014. This universal port is a true testament to the evolution of technology. With its reversible plug orientation and cable direction, it has nullified the age-old problem of trying to insert a USB the wrong way. Not only does it support various protocols, it also provides power supply, making it a highly versatile and user-friendly port. These modern ports have ushered us into a new age of high-speed and high-quality data transfer. They have streamlined our digital experiences and allowed us to enjoy the benefits of technology in a more seamless and efficient manner. As we gaze into the future, what can we expect from the evolution of electronic ports? Well, if the past is any indication, we're in for an exciting ride. With each passing year, technology becomes more advanced, more efficient, and increasingly integrated into our everyday lives. The electronic ports of tomorrow will likely continue this trend, pushing the boundaries of what's possible, while also striving for simplicity and ease of use. One potential game-changer on the horizon is the rise of wireless technology. As devices become more interconnected, the need for physical ports may decrease. Imagine a world where your smartphone, laptop, and smart home devices all communicate seamlessly, without the need for cords and cables. It's a tantalizing prospect, but one that also presents new challenges in terms of security, power efficiency, and reliability. Meanwhile, the importance of backward compatibility cannot be overstated. As new port standards emerge, it's crucial that they maintain compatibility with older devices and technologies. This is a delicate balancing act, pushing the envelope while ensuring that no one gets left behind. Keeping up with technological advancements is another key challenge. The pace of change in the tech world is relentless, and the ports of the future will need to be able to accommodate new types of devices, new data transfer protocols, and new power delivery methods. It's a tall order, but one that the industry has proven time and time again that it's more than capable of meeting. As we look forward, it's clear that the world of electronic ports is set to become even more diverse and dynamic. Whether it's through the development of entirely new port standards, the incorporation of wireless technology, or the refinement of existing designs, the future is bright. The journey of electronic ports, from the humble parallel port to the versatile USB-C, is a testament to the relentless pursuit of innovation in technology. And as we move forward, it's thrilling to imagine what the next chapter in this story will look like.